Hello everyone, welcome to our channel. So in this series we are taking one more question. This question related to the time domain. Actually, this question very simple. They giving the first order transfer function related question they are asking. Okay, so all right. So I'm stating the question. The consider a permanent magnet DC motor which initially at rest. So it means initially rest means our initial condition 0. Alright, initial condition 0. Okay, and t is equal to 0. And you know, in a transfer function is only applicable for the without neglecting the initial condition. Okay, so this is also we should know here. Okay, and the given t is equal to 0, DC voltage of 5 volts applied to the motor, and its speed monotonically increases from 0 radian per second to 6.32 radian per second. Okay, in zero point 0.5 second. All right, finally settles to 10 radian per second. So they given the final value also 10 radian per second. Assuming that armature inductance of motor is negligible, the inductance of motor is 0. Okay, and transfer function for motor is they need to find out. All right, so here like how to solve this question very simple. Like for example, this is a PM DC motor. This is open loop system. Okay, no matter how much, just give you the input and find out the output. This is our input we are giving in terms of voltage. So this is 5 volt and this is our 10 radian per second finally we are getting. All right, so here if you Laplace domain, so this is a upper RS, we can say capital A RS 5 by S, this is 10 by S. I'm just speed there now, so this is your capital omega S. Okay, radian per second. So since we are giving the input, this is a 5 and we are finding this is volt actually, make sure. Okay, 5 and we are getting the speed is finally is 10 radian per second. Okay, so as we know for first order transfer function, and one more thing here, first order transfer function, what's the this is speed actually, what's the useful data required. So you know general form of first order transfer function with this again k. Okay, this again k and time constant t is given, the given, we can find out the transfer function k by 1 plus s tau. Okay, so this again k. And what is your time constant? Now our first order transfer function, first order system, the time constant is a time taken for output that increases monotonically to reach the 63.2% of its final value. Okay, so how much time would take to reach this percentage of final value? Then it is called the time constant. So here in our given question, and they also given one more details like point 0.5 second our speed reaches to 66.32 radian per second. All right, and finally settle to 10. Okay, okay now 10 radian per second. So this 6.32 and we achieve the speed at a zero point 0.5 second. As we know, this 6.32 is a equal to 63.2% of the final value, which is 10. All right, so we can say 0 0.5 second is nothing but this is time constant itself. Okay, so can we say this is tau at t? Okay, 0.5 second. So let me write here like our first order transfer function. I am just calling GS is k by s t plus 1. Sometimes people also call k by s tau plus 1. So this is no problem. Okay. And we know t or tau, we know the 0.5 second which is given in the question. All right. Okay. Our only concern that how to find out the k value. Okay. For this they also given the final value. All right. 10 radian per second. So we can also interpret like that. We can also write down like output is speed omega s, and by speed and by input we are feeding the input supply voltage bs equal to k by s tau t plus 1. We can also write, because we know the t value, I mean time constant value, we can also write 0.5 s plus 1. Okay. So finally what is a speed expression? So we get k into bs by 0.5 s plus 1. All right. And then we can finally we can also write down the input transfer function input value. So this is a 5 by s. All right, because we are feeding the 5 volt step input, we can say. All right, at t is equal to 0. Okay, so hope you understood. This is our input volt. Okay, so here we need to find out the final value theorem. I mean apply the final value theorem so that we can find out the k value, because k here unknown. Okay, so you know our final value theorem is like here in terms of speed. So omega final value when time dies out means t tends to infinity. Okay, that means system gets settles. Then omega t in terms of time we can find out in terms of Laplace using the Laplace domain. This is a s capital omega s. All right. So this expression very important here, and we know our final value theorem has limitation is only applicable for the left stable system. All right. Okay. So here, how to find out? Let me. They given this value also. Final value theorem. The given value is 10 radian per second. So 10 by equal to limit s tends to 0 s omega s. All right. Okay, so the 10 and then limit s tends to 0 s omega s is a k into 5 by s into 0.5 s plus 1. Alright, s cancel out. Then finally we can apply the limit s tends to 0, then 5k equal to 0 plus 1. So k we can get 10 by 5 is equal to 2. Okay, so finally we get the our transfer function gs equal to 2y s 0.5 plus 1. Okay, so our given question answer would be 2y 0.5 s plus 1. Then answer is correct. B option is correct. All right. So here like our no need to go for find out the transfer function in a standard way. Just apply the final value theorem here in all option. Straight away we can get the answer. All right. So in our exam we always apply the shortcut. Okay. so that very fast we can find out this answer. All right. So, and one more thing actually, this is a open loop system. Okay. Like open loop system, like input they given 5 volt, find out the output, because we don't know the reference value here. Input we don't know how much, reference value we want. All right. So here we cannot you know simple, keep the simple, like they give in the input and find out the output. And one more thing here that I'm also telling here, like in case of motor, generally our transfer function like that, 1 by Lm into S plus Rm, where Lm is a inductance and resistance of the coil, I mean motor. Okay, binding inductance and resistance of the coil, and this is our current in ampere, and this is our voltage, supply voltage Vt, and this minus is our back EMF voltage, and this is a constant, we are giving the back EMF constant. Okay, then again here multiply the our torque constant Kt. So coming torque constant Kt in Newton meter per ampere. Finally we get the torque here, generated torque. All right, then multiply our again in this is like mechanical part. Okay, this is our the electrical part. Okay, so Jm S plus Bm. All right, finally we get the speed, and speed you can just multiply, we get the back EMF. So here you can see the second order system till speed. But if you neglect the inductance, we get the further you can simplify, like this is Rm. I'm just explaining here how we get the first order transfer function. Okay. This is Vt, this is EV, kV. Okay, so here you can see this is first order transfer function like. Okay, so that's why we are applying a first order transfer function when we neglect the our inductance. Okay, if you go for position, then it's again going to second order. Once we neglect the inductance, we don't neglect it, then coming the third order. So like that we should know. Okay, so question was very simple. We should know the our final value theorem, how to apply it. Okay, we should also know the time constant, how to define the time constant. All right, so then easily we can find out. Otherwise, if you know the final value, then easily final value they given 10 reading per second, so people just find out the output, I mean speed. So how to speed coming gs into 5 by s, and final value is coming, apply final value, then s tend to 0 into s. If you apply the final value, then limit s tend to 0, s into gs into 5 by s. Then straight away they can find out 5 into gs by s, they can find out what is the final value. Okay, so hope you understood. Okay na, so that's all for this video. Question was very simple. Okay, generally in GATE exam, generally they touch the fundamentals of control system, we should know. Okay, they deal with the steady state error, times and certain time, rise time, like that the question generally ask. Okay, so that's all for this video. Okay, if you any doubt, please do comments. Okay, so that's all. Thanks a lot.